In this orthokeratology case, the main concern is that the two diopters of refractive cylinder that the patient started with didn't really go away very much after lens wear. There's still about a diopter and a half left after wearing lenses. And so in a case where there's a fair amount of cylinder and it very closely matches what's on the cornea, I think it is usually warranted or necessary to make some meridian-specific changes. So before doing that, though, one thing I noticed was in the different meridians, we have some variability in the base curve. So, for example, here at an 837 compared to here at an 842, we have almost a quarter diopter difference. And in this case, it happens to be that the superior meridian is a little bit steeper than the horizontal, and especially with the littoral cornea, it's something that we don't want. That will make it harder for us to mold out this cylinder. So this variability in the base curve often comes from manually changing the base curve by clicking up or down at the red control point, especially if you're in freeform mode. So anytime you change the base curve, it's a good idea to click through each meridian and see if it is uniform. And it's not really uniform, so what I'm going to do is probably click up a couple times. And then we'll go into 25% mode and fine tune each one. So now it looks like we're at 842, pretty close to 842 all the way around. And I think this will be a better starting point. So now for the meridian-specific changes, the patient's post-treatment refraction is plus 150, minus 150, axis 178. So in this case, it's not that we are insufficiently molding the vertical meridian. The vertical meridian is actually okay. We're just getting too much molding in the horizontal meridian, where we don't need as much because this is a littoral cornea corresponding to littoral refraction. So to decrease treatment in the horizontal, we can do a toric base curve, where we just make the base curves steeper in the horizontal. Another way to do it is just to reduce how much seal off we have at the back of the reverse curve. We don't seal off very well, then we'll get less treatment, and less treatment is pretty much what we want in this meridian. So these changes will be in 50% mode, and what we want to do is see where we're starting from, 914 and 1931 here. I think it's a good idea to jot those numbers down because we'll refer back to them. And what I'm going to do is decrease sag here at the blue control point by 30 microns. So it's going to be a pretty significant change. Our new target is going to be 30 microns will be 884. And we're at 884. Now we've lifted the edge of the lens way off the cornea as well, and we don't necessarily want that. We want less seal off here, but we still want the edge of the lens to land on the cornea. We get too much lift out here and across the horizontal, then we risk the chance that this lens starts to decenter to the left or right. So we started here at 1931, and we will just bring this control point back down to 1931. And that one shifted a little bit. And maybe we'll go with this one here. So we're now at 884 and 1930. The lens does look a little bit odd, but this should help us get towards the goal that we're after. This is just right eye, so this is just the nasal side lens. We need to make the same change to the temporal side. And similarly, we're starting from 914 and 1954, so we're going to want to lift the IC point up to 884, but then return the edge back down to 1954. This lens is already prism ballasted, which I think we want to retain in the next design and should help the patient get closer to the refractive target that we're after.